Welcome to the MSBT online learning platform. We bring you the most relevant content in an exciting digital format. Today we'll be studying a very interesting module from Applied Mathematics Integral Calculus, which includes the topic Indefinite Integration, where we will be studying some interesting facts about integration of standard and composite function, and we will be practicing some of the examples based on it. So let's begin. So let's begin with our module Integral Calculus, in which we will study topic Indefinite Integration part 2. So let's see the objectives for this session. To study integration of standard function. In this we will study how to solve simple problems based on standard function. To study integration of composite function, in which we will see what is composite function and how to solve sums based on composite function. Now we'll see examples of standard function. Before going to the examples, what is standard function? If you have got any function in which the variable part is x, then you can say that the function is standard function. Now let's see the examples of standard function. Let's come to the first example. Evaluate integral e raised to x plus x raised to e plus e raised to e dx. Okay. Now see the first step. Let I equal to integral e raised to x plus x raised to e plus e raised to e dx. What we have done in this first step? We have denoted the given integral with the symbol I. Let's see the next step. Now, as per our rules of integration, if we have got two or more functions with plus or minus in between, we can separate them out. So by using that rule of integration, we have separated these three functions. You can see here, first thing, integral e raised to x dx plus integral x raised to e dx plus integral e raised to e dx. So what we have done here, simply used the second rule of integration and separated the three functions. Now in this next step, the first two parts are kept as it is. See the third part. Now in this third part, if you see e raised to e integral dx. Now what is e raised to e? This e raised to e is nothing but a constant value, and hence it is written outside the integral. If you recollect your first rule of integration, integral k f of x dx equal to k into integral f of x dx, which means that if there is a constant value inside the integral symbol, we can take it outside the integration symbol. So e raised to e, which was written inside the integral, we have taken it outside the integral symbol, and now we get e raised to e integral dx. Now see the answer. We are applying the formulas to get the answer. Integral e raised to x dx we all know is e raised to x. So integral e raised to x dx we are getting as e raised to x. Come to the second part, integral x raised to e dx. Now this is nothing but x raised to n. Since e is a constant, so x raised to n indicates variable raised to constant, and since it is variable raised to constant, we need to use the formula integral x raised to n dx. So by using the formula integral x raised to n dx, which is x raised to n plus 1 upon n plus 1, instead of n in this sum we have got e, so the answer will be x raised to e plus 1 upon e plus 1. That is the answer for the second part. And come to the third part, e raised to e integral dx. Now we all know that integral dx is nothing but x, so the answer will be e raised to e into x. Answer for the third part, the total answer you can see e raised to x plus x e raised to 1 plus x upon e plus 1 plus e raised to e into x plus c. Come to the second example. Evaluate integral 1 upon 1 plus x square minus cos x upon sin square x dx. Let's see the first step. Let I equal to the given integral, just indicated the given integral with the symbol I. Now as per our rules of integration, we can separate out two integrals if there is plus or minus in between. So we have separated the two integrals. The first integral, integral 1 upon 1 plus x square dx. The second integral, integral cos x upon sin square x dx, in which the denominator, that is sin square, is split into two parts. Obviously sin square is nothing but sin into sin. So we have written integral cos x upon sin x, that is the first part, into 1 upon sin x dx. Come to the next step. The first part remains the same, integral 1 upon 1 plus x square dx, minus, now you can see cos upon sin is nothing but cot x. So instead of cos upon sin, we have written cot x, and 1 upon sin is cosec x. So we get integral cosec x cot x dx. See the next step, integral 1 upon 1 plus x square, formula for integration, the answer is tan inverse x, minus integral cosec x cot x dx, the formula is minus cosec x. So we get the answer as tan inverse x minus of minus cosec x plus c, and that is the final answer, tan inverse x plus cosec x plus c. Let's see the next example. Evaluate integral x into x minus 1 square dx. Let I equal to integral x into x minus 1 square dx. Now see the first step. We have kept the x as it is and applied the formula a minus b the whole square to x minus 1 the whole square to expand the given part, that is x minus 1 the whole square. Now why we are doing this? We are doing simplification because there is no direct formula in integration to write the answer for integral x into x minus 1 the whole square dx. So we need to simplify first, get the answer into the correct formula type, and then apply the formula and get the answer. So we are first simplifying the given part. The x remains as it is, and instead of x minus 1 square, we are using a minus b the whole square formula. So we are getting a square minus 2ab plus b square, that is x square minus 2x plus 1. Open the brackets. X into x square will become x cube, minus 2x into x will become 2x square, plus x into 1 will become x. Next step, we will separate the three integrals inside the bracket. Since we have rules of integration which says that if there is plus or minus of two or more functions, we can separate that out. So we will separate out the three parts which are there inside the integral. You can see here integral x cube dx minus, we have got the constant outside, 2 integral x square dx plus integral x dx. Now we can apply the formula in all the three integrals. The formula obviously will be x raised to n, because in all the three parts you can see the first part x raised to 3 which is variable raised to constant, the second part x square again variable raised to constant, and the third part x raised to 1 which is again variable raised to constant. So we will use the formula for integral x raised to n, which is nothing but x raised to n plus 1 upon n plus 1 plus c. So you can see here x raised to 3 integral becomes x raised to 4 upon 4 in minus 2 into integral x square dx is x cube upon 3 plus integral x raised to 1 is x raised to 2 upon 2. So final answer is x raised to 4 upon 4 minus 2 into x raised to 3 upon 3 plus x raised to 2 upon 2 plus c. I hope all the students have observed the use of the formula x raised to n in this particular example. Similar example we can see here. Evaluate integral x minus 2 square upon x dx. Now again this is an example based on integral x raised to n dx. Now how we are going to solve this? Let us see the steps one by one. First step, let I equal to integral x minus 2 square upon x dx. Obviously we have denoted the integral with the symbol I. Now we will simplify the given integral. Now why do we require simplification? Because there is no direct formula which can be used to get the answer for the integration. Hence we need to simplify the integral that is given. So what we are doing here in this next step, you can see here, x minus 2 the whole square, that is nothing but a minus b the whole square, which is a square minus 2ab plus b square. So we are applying the formula a minus b the whole square to get the answer. What is the answer? X square minus 4x plus 4. Denominator x remains the same. Now come to the next step. Now here we have used rules of integration. We have separated the three parts and the constant terms we have taken outside. So in the first part that you are seeing, integral x square upon x dx, this is the first integral, minus the constant 4 we have taken outside by using rules of integration, and we get integral x upon x dx, plus again the constant 4 we are taking outside, so we are getting 4 integral 1 upon x dx. Now in the next step, obviously x square and x will get cancelled, we will get integral x dx. In the second part, x and x will get cancelled, we will get integral dx, and in the third part 1 upon x will remain the same. So you can see this next step, integral x dx minus 4 integral dx plus 4 integral 1 upon x dx. Now here all the three parts we can apply the formula. Now integral x represents x raised to n, so we will use the formula for x raised to n. The second part, integral dx, we have got a direct formula x, and the third part, integral 1 upon x, again we have got a direct formula log x, so we will get the answer x square upon 2 by using the formula integral x raised to n dx, minus 4 integral dx would be x, plus 4 integral 1 upon x dx would be log x, and we will write the constant of integration c. So we will get the final answer x square upon 2 minus 4x plus 4 log x plus c. Now we come to the next example. Now this example, evaluate integral 1 upon x square plus 4 dx. This is an example based on algebraic integration, formulas for algebraic integration. Now see here, let I equal to integral 1 upon x square plus 4 dx. Now here we are representing the integral by using I. Now as I have already told you, we need to match the given integral with the formula type. So here what we are doing, instead of 4 we have taken it as 2 square. What that does is that it matches the given integral with the formula integral 1 upon x square plus a square dx, and the formula for integral 1 upon x square plus a square dx is nothing but 1 upon a tan inverse x upon a plus c. So by using that formula we can get the answer as 1 upon 2 tan inverse x upon 2 plus c. What we have done, simply substituted the value of a, which is 2, in the formula, and we get the answer. Now let's come to the next example. Evaluate integral tan square x dx. Now if you can see the given integral, in that we have to integrate tan square x dx. Now do we have any direct formula to integrate tan square x? The obvious answer is no. So what we are going to do, we are going to simplify this tan square x first and then apply the formulas to get the answer. Let's see the first step. Let I equal to integral tan square x dx. Obviously denote the integral with the symbol I. Now as I told you, tan square x does not have any direct integration formula, so we need to think how we can simplify this tan square x and convert it into formula type so that we can apply formula to get the answer. So now if you see what is given, tan square x. So I know that sec square x minus tan square x is equal to 1. So you can see here sec square x minus tan square x is equal to 1. This is a standard formula for trigonometry. Now in this you can see that if we rearrange the terms, we will get tan square x is equal to sec square minus 1. What we do is we transfer the minus tan square on the RHS, so we get tan square x, and we transfer the 1 on the LHS, it becomes minus 1, so we get tan square equal to sec square minus 1. Now this sec square minus 1 can be substituted instead of tan square x in the given integral. Now why this formula only? Now we are using this formula because Once we use this formula and we get the answer for tan square as sec square minus 1, you can observe that sec square x has integration direct formula and 1 also has integration direct formula. So we can apply the formula to get the answer. So that is the reason why we are using this particular formula of trigonometry. Now we substitute tan square x as sec square minus 1 and we get this next step. You can see integral sec square x minus 1 dx. What we have done, instead of tan square x, we have put sec square x minus 1. Now next step, we separate the two parts since there is minus in between. So we get two different integrals, integral sec square x dx minus integral dx, and now you can see we apply the formula for integration. We know that integral sec square is tan x and we know that integral dx is x. So we get the answer integral sec square x dx, we get the answer as tan x, integral dx we get as x. So we get the final answer as tan x minus x plus c. Now see here the definition of composite function. Function within another function is called as composite function. As in, we will have one function and inside that one function we will have another function. If we have one function within another function, it is called composite. For example, you see here y equal to sine 2x. Now in this example you can see that we have got function sine and inside the function sine we have got function 2x. So we have got one function within another function, so it is composite. Same goes for the second example. You can see that inside function cos we have got log x, so we have got one function within another function, hence it is composite. If you recollect, as I had told you, in standard function we will have variable x, in composite we have got variable which is something other than x, which is the trick which is used for identifying the composite function, as you can see here. To identify composite function, what we have to do, you see the concept that is given, we check the variable part and we see what is the variable part. If the variable part in a given function is x, then it is a standard function. If the variable part is anything other than x, then it is a composite function. If you recollect the previous two examples, in the first example we had y equal to sine 2x. In that the variable part was 2x, which was something other than x, so it is composite function. In the second example, the variable part is log x, which is again something other than x, so it is composite function. Now come to the next part, how do we integrate composite function? So we have got 2-point solution for the same, which you can see now. To integrate composite function, this is the 2-point solution. First point, you can see formula remains the same as standard function, which means those formulas which we have used for standard function, the same formulas we will use for composite function and we will get the answer. And the second step is we divide the answer by the derivative of the composite part to get the final answer. By following this 2-point solution, we can integrate composite function, which are shown in these two examples. Come to this first example, integral cos 2x dx. The first thing, you need to identify the function whether it is a standard or composite. So if you recollect, I told you, you check the variable part, see the variable part, if it is x it is standard, if it is anything other than x then it is composite. So in this given integral the variable part is 2x, which is something other than x, so it is composite. Now as per my 2-point solution, formula remains the same. So what is the formula for integral cos x dx? The formula for integral cos x dx is sin x plus c. So here also the formula will remain sine. So we will get the answer as sin 2x, that is the formula for integral cos 2x. And then if you see step number 2, we divide the answer by the derivative of the composite part to get the final answer. So we divide sine 2x by derivative of 2x to get the final answer. So we will have the final answer as sine 2x upon derivative of 2x is obviously 2. So sine 2x upon 2 plus c would be my answer. As you can see, what we have used here is 2-point solution, which is given previously to get the integration for the composite function. One more example you can see here, integral e raised to 2x dx. Now in this again you can see the function e raised to 2x. The variable part is 2x, which is something other than x. It is not x, something other than x. So it is composite function. Now as per the 2-point solution, point number 1, formula remains the same. So what is integral of e raised to x? The integral of e raised to x is e raised to x. So integral e raised to 2x will remain e raised to 2x. And point number 2, we divide the answer by derivative of the composite part, that is 2x, to get the answer. So the final answer would be e raised to 2x upon, obviously derivative of 2x is 2. So e raised to 2x upon 2 plus c. So in both these examples, it is clearly illustrated how to use the 2-point solution to get the derivative, to get the integration of the composite function. Do you have any questions, students?
Yes, sir. I have one question. How to identify composite function?
Okay. So you have a query regarding identification of composite function. So you have just seen standard function, you have studied standard function, and now we are about to study composite function. So in order to identify composite function, what we are supposed to do, we are supposed to check the variable part in the given function. If the variable part is x, then the function is standard function, and if the variable part in the given function is anything other than x, then the function is composite function. Hope you have cleared your doubts.
Yes, sir. Thank you.
One important note to be remembered in this point, above 2-point solution for integration of composite function is applicable only when the composite function has variable part as px plus q. If you recollect the two examples which we have just seen of composite function, the first one, y equal to sine 2x, in that the variable part was 2x, which was in the form of px plus q. So we could apply the 2-point solution there. So you can see here, if the function is sine 2x, we can apply the 2-point solution. But if you have the function as cos of log x, you see the variable part, it is log x, it is not px plus q. So in such cases, you cannot apply the 2-point solution. So you have to remember that the 2-point solution is applicable only when the variable part of the composite function is of the form px plus q. Now let's come to few examples of composite function. Let's take the first example. Evaluate integral e raised to 2x plus 1 upon 1 plus x square dx. Indicate the integral with the given symbol of I. Now in this integral you can see that two parts are there separated by the plus sign. So obviously we will separate the two parts by using the rule of integration. You can see here we have separated the two parts, integral e raised to 2x dx plus integral 1 upon 1 plus x square dx. Now you see the part which is the first part, integral e raised to 2x dx. Now if you see the part properly, the function is e raised to 2x, in which the variable part is 2x, which is something other than x. So it is nothing but composite function, plus if you see the variable part 2x, it is nothing but px. So it is in the form of px plus q. So we conclude that we can use the 2-point solution to get the answer for integral e raised to 2x dx. If you see the second part, integral 1 upon 1 plus x square dx, it is a standard function whose formula is tan inverse x. So in the next step, you can get the answer for the integration e raised to 2x upon d by dx of 2x. This is nothing but the 2-point solution used for integrating the composite function plus tan inverse x, the answer for integral 1 upon 1 plus x square, which is the standard function, plus c. So the final answer would be e raised to 2x upon 2 plus tan inverse x plus c. That would be the final answer. Let's see the next example now. Evaluate integral x plus 1 upon x minus 1 dx. Okay, so let's solve this example. Initially we will denote the given integral with the symbol I, as we have done previously. So let I equal to integral x plus 1 upon x minus 1 dx. Now if you see this particular integral, it is a algebraic part that is given x plus 1 upon x minus 1. Now in this, what we are supposed to do, we are supposed to match the numerator with the denominator first. It means in the denominator there is x minus 1, so we want denominator in the numerator, so we want x minus 1 in the numerator. So how we will do that? What we will do is, since we want x minus 1 in the numerator, we will first put minus 1, but if we put minus 1, to balance it we will have to put plus 1 along with it. So you see this step, you can see in the numerator x plus 1 was there. Now we have written x minus 1 plus 1 plus 1. This minus 1 and plus 1 is the manipulation part that we have carried out in the numerator, so that we can get x minus 1 in the numerator. Now let's see the next step. In the next step, the 1 plus 1 in the numerator will become 2. So we will get two parts in the numerator. The first part will be x plus 1, the second part will be 2. Now you see this step. So as you can see, in the numerator we got x plus 1 and the other part is 2. Now we will separate out the numerator. So you can see here x minus 1 upon x minus 1 dx, this is one integral that we got after separating, and we got 2 upon x minus 1. The 2 constant goes outside the integral, so it becomes 2 into integral 1 upon x minus 1 dx. Now in the next step, what we will do, we will cancel x minus 1, so we will get integral dx, which is a standard formula whose answer is x, and the second part, integral 1 upon x minus 1, is a composite function, so we will use the 2-point solution to get the answer for the same. So you can see here integral dx has become x, the constant 2 remains the same, and integral 1 upon x minus 1. Now you see the 2-point solution. Point number 1, formula remains the same. So 1 upon x minus 1, the corresponding standard part for the same is 1 upon x. Integral 1 upon x is log, hence the answer remains log. So we will get log mod x minus 1, and point number 2, we divide the answer by the derivative of the composite part, so d by dx upon x minus 1 plus c. Now in the next step, we will take the derivative of x minus 1. Derivative of x minus 1 obviously is 1, so we will get the answer as x plus 2 into log of mod of x minus 1 plus c, as you will see now. So this is the answer, x plus 2 log mod x minus 1 plus c. Let's see the next example now. Evaluate integral sine square x dx. Initially, we will denote the integral with the symbol I. So let I equal to integral sine square x dx. Now if you see the integral that is given, sine square x, if you recollect the formulas that are given to you, you will understand that there is no formula to get the direct answer for integral sine square x dx. So obvious thing that we are going to do, we are going to simplify sine square x so that we can convert it into a formula type of integration. Once we do that, we can apply the integration formula and get the answer. So the first step is not to integrate but to simplify. Now think of any formula which contains sine square x, which can be also integrated. So which is such formula which contains sine square x and whose integration formula is available? So we will think of the formula. We will realize that we have got formula for cos 2x in which sine square x is present. So see the formula, cos 2x, which is nothing but 1 minus 2 sine square x. Now in this you observe the term sine square x is present. So we are using this formula. We will rearrange the terms. We will get 2 sin square x is equal to 1 minus cos 2x. Take the 2 on the other side. It will go in the denominator. We will get the answer for sin square x, which is 1 minus cos 2x upon 2. As I told you, we are using this formula because it contains the term sin square x and the part cos 2x can be easily integrated and the answer can be obtained for the same. Hence, we are using this particular formula. Now see, we got sin square x as 1 minus cos 2x upon 2. So, we will put it in the integral. So, you can see here we have put instead of sin square x 1 minus cos 2x upon 2 dx. Now, half will come outside since it is a constant and we will get two integrals inside, integral dx minus integral cos 2x dx by separating the two parts. As you can see here, integral dx minus integral cos 2x dx. Now, integral dx is a standard function whose answer is x. So, we will write that, and then integral cos 2x is nothing but composite function. So, we will apply the 2-point solution to get the answer for that particular part. So, you can see here half remains same, integral dx will become x minus integral cos is nothing but sine. So, we will get sine 2x. And point number 2, divide the answer by derivative of the composite part. So, we divide the answer by derivative of 2x, which is nothing but the composite part, and we add the constant of integration plus c. Next step, the derivative answer of 2x is 2. So, we will get the final answer half into x minus sine 2x upon 2 plus c. Objective number 1 that we have studied in this session, that is to study integration of standard function, and objective number 2 that we have studied in this session, to study integration of composite function. We proceed to next session of indefinite integration, that is methods of integration with the knowledge and the concepts of standard and composite function which we have studied in this session. Now, this is a useful tip which students can use in case they need to verify their answers. Now, we all know that integral 1 upon 2x plus phi dx is log mod 2x plus phi upon 2 plus c. This is composite function 1 upon 2x plus phi, whose answer we have obtained as log mod 2x plus phi upon 2 plus c by using 2-point solution. Now, if we want to verify this answer, what do we need to do? As you all know, integration is nothing but antiderivative. So, if the answer of integral 1 upon 2x plus phi dx is log mod 2x plus phi upon 2, then obviously by definition of integration, the derivative of log mod 2x plus phi upon 2 should be equal to 1 upon 2x plus phi. So, let us obtain derivative of log mod 2x plus phi upon 2 and see what answer we get. Let us obtain the derivative. You can see here half is a constant, it comes out of the derivative symbol and we get derivative of the log term. Now, since it is a composite function, we will first take the derivative of log, then we will take the derivative of 2x plus phi, and then we will take the derivative of x. As you can see, half is written as it is. Derivative of log is 1 upon 2x plus phi, and then we take the derivative of 2x plus phi, which is nothing but half 1 upon 2x plus phi. These terms remain as it is. Derivative of 2x plus phi is nothing but 2 into 1 plus 0, which is nothing but 2. Remaining terms as it is. The half and 2 will get cancelled and we get 1 upon 2x plus phi, which is the given integral. So, we can see that by obtaining the derivative of the answer, we can get the integral and we can check whether our answer is correct. Now, you are fully competent to solve problems of standard and composite function of indefinite integration. So, worksheet is given below. You can try to solve it and see whether you understood the concepts of standard and composite function. Solution of these worksheet is provided for cross verification. Evaluate integral 1 upon under root 1 minus x square minus cos x dx. Now this is a simple problem. You have to just separate out the two integrals that are given and apply the formula for integration. You get the answer. Let's see this second example. Integral 2x plus 3 upon 2x minus 1 dx. In this you can see we have done the manipulation. In the second step, minus 1 plus 1. Then we have duplicated the numerator like the denominator, so that you can see 2x minus 1 is there in the numerator as well as denominator. Separating the two integrals now and applying the formulas, standard function for integral dx and composite function for integral 1 upon 2x minus 1. Hope you remember to divide the answer of the composite part by derivative of the composite part, that is 2x minus 1. This is a common mistake that most students make. They don't divide the answer by derivative of 2x minus 1, that is why they get the answer wrong. So derivative of 2x minus 1 is 2, and hence 4 and 2 will get cancelled and you will get the answer as x plus 2 log mod 2x minus 1 plus c. So ensure that you are taking the derivative, you are not committing the mistake there. This is the next example based on formula integral x raised to n. You can see here we have simplified the given integral, that is root x into 1 plus x dx. We have simplified it, separated, got x raised to n format, applied the formula here of x raised to n and got the final answer. Let's see one more example. Integral cos cube x dx. In these, see the usage of the formula cos 3x, how we have obtained the term for cos cube x and substituted it in the integral. That is the main part that you have to observe carefully. You must understand which formula to use here. The formula used here will be cos 3x primarily because of two things. First thing, it contains the term cos cube x which is given in the integral which we want, and second thing, by using this formula we will get cos 3x which is nothing but a composite function which can be easily integrated by using 2-point solution. So use of formula and the way in which the term is substituted in the integral, these are the main points that you have to observe in this integral. This is the further solution. Integral cos is sine and integral cos 3x, you can see we have applied 2-point solution to get the answer. This is the final answer, 3 upon 4 sin x plus 1 upon 12 sin 3x plus c. Come to the next problem. Evaluate integral tan x plus cot x the whole square dx. This is a standard function problem based on trigonometric part. We use the expansion for a plus b the whole square. Simplify the problem. Instead of tan square we have put sec square minus 1. Instead of cot square we use cosec square minus 1 to convert the integral into formula type. Then apply formula integral sec square x dx and integral cosec square x dx to get the answer tan x minus cot x plus c. Come to the last problem of this worksheet. Integral cos 8x into cos 2x dx. Again in this you have to observe carefully the usage of the formula. In this we have used the formula for 2 cos a cos b, which is the defactorization formula. Accordingly, we have written the term cos 8x plus 2x plus cos 8x minus 2x upon 2 by using the formula which is given below. Observe the use of formula carefully. Now, because of the use of formula, we have got composite function integral cos 10x dx and cos 6x dx, which we integrate by using 2-point solution, and we are getting the answer sin 10x upon 20 plus sin 6x upon 12 plus c. After studying integration of standard and composite function, we can proceed to the next topic, which is nothing but methods of integration, in which you are going to study substitution, integration using partial fraction and integration by parts. You have learned some important topics so far. We hope you have good time learning with us. Browse through our online library for more content on the MSBT portal, online platform, digital content. Thank you, stay connected and happy learning.